Recording.
All righty. Power supplies, T-11. It's a relatively short one, kind of quick, but a lot of important information. Some of it we have already kind of addressed. The objectives within this particular one is going to be identifying the characteristics of power supplies and the connectors that we use. Select the power supply based on given specifications. Describe how to remove and reinstall a power supply. I'll give you a hint. It's very similar to almost every other component we've talked about thus far. Identify common problems that come up with power supplies and how to address them. Behavioral skill, communication. As we've stated, IT is a team sport. It's typically not any given person in that team is going to know every single component, and be able to maximize, repair capabilities and all that stuff. Some of you may be more focused on telecom. Some of you may be focused on data. Some of you may be more hardware oriented. So you have to work in a team. And also many of the, often we will be set upon a task that we cannot complete within our time frame of working in the office. So we're going to have to hand that over, and we have to be able to effectively and efficiently communicate that to our team members to ensure that these projects get completed on time and ready to go for the customer, be them internal or external. If we fail to make that connection or communicate that, that sets us up for failure as a team. Also, growth mindsets. Continual learning, continual development, continual growth, be it 15, 20 minutes a day, that's all you have available to you, or in a program like this, where we're spending significantly more time. Yes, Will.
Excuse me. Yes, Professor Colley. I unmute myself now. You mentioned about it's a team sport. Is this true? Like when there's going to be when we are in the field in CompTIA as a IT support specialist, let's say for example, I've heard this, but I want to really hear from you. When we get a ticket, we're not going to be able to resolve this, or like, is it normal when we first start that's always going to happen? Like, oh man, I'm going to have to pass it down to a higher tier or something like that, or is that or there'll be situations where, okay, I can handle this, or I'll be able to pick it up, or is that normal? Like, what's
got a couple examples, Kelly?
Yeah, since you brought that up, since it's a team sport, I just wanted to hear about that. Thank you.
Yeah, absolutely. Go ahead, Marvin.
I worked in a department of 4. It was me, 2 other young ladies, and my manager. And as tickets came into the department, it depending on what the ticket required. It could be something that I could address. Say, for instance, somebody locked themselves out of an application, I can reset that. But if it required other parties to be involved, what I had to do in the ticketing system was put in the part that I did and say that PAX part, I actually had to, this is the line, PAX part done. And other people would see the ticket and I would forward it to make sure, hey, you're next in this role, you're next. And it was a whole nother department. It could have been it was the EPIC, the EMR department. They had to do their part, but I had to do my part first before they did theirs. So it's a very team-oriented sport. Or if I had to do something and had to call the other IT area to ensure that they were ready to do their part, we just had to keep everybody on the same page. But if it's something that happens within that department that I could handle, or maybe I could, but couldn't at the time, it was not uncommon for me to ask Martha or Lisa, hey, Lisa, can you finish this up for me? This is what I've done. But then there may be times where you are IT. Bingo, you're hired, you're IT, and you do everything. So you just gotta, it just depends on the situation you find yourself in, William. But if there is more than one person in the department, you work better when everybody's as strong as the weakest link. So their goal, when I was the newest person in my department, they made sure that I was properly trained because they wanted to not have to take call all the time. They wanted me to take, like, so it's like a selfish thing, but it's a real thing. If you get trained up, then they can ensure that you can do the job without too much assistance. But if they need the help, they're
Right.
willing to help.
It depends on the situation now. Okay, I got you.
Depends
I
on the
got you. For
situation.
now.
And
Gotcha.
yes, you're gonna rely heavier on documentation, personal research, and your teams a lot heavier in your first 6 months in IT than you will going forward. So those first 6 months, you're going to have to get quick at looking things up and, being able to use the internal documentation, using Google, YouTube, all these other resources, being real fast and efficient and getting out there and getting that information you need.
Yeah.
Because that's your first 3 tiers. It's your personal information, internal documentation, Google, and external, before you want to reach out to your team members and say, hey, I've done this, and this. Can you possibly help me with this one? And then pay attention when they're solving that problem so that you can be more aware of it going forward. And then if neither you nor your team members can figure it out, then escalation happens. And depending on the severity of the issue, that process may only take 5 minutes between when that first call comes in to when you're escalating it up to a supervisor, depending on the severity. Now, other issues you might have a little more time to work on where, it's a background issue with the customer. They're still working. It's not preventing them from working. So you have a little more flexibility in working on that issue. And that gives you the time to kind of do that research and plug away at it and stuff like that versus, we have a server down right now and we're unable to operate. So that escalation is going to happen really quickly.
Wow, it's good to know. Wow, got it.
Yeah. So, but yes, definitely in the beginning, you're going to rely heavier on your research and your communication with your team members. And a lot of times in the industry, they're going to know you're new. They're going to know it's your first time in a tech support environment. And your good teammates are going to be the ones that are going to be like, hey, let me show you how to do this, because they're going to want you to develop as quickly as possible so you could be a valuable member of that team.
Right, capiche. Got it.
So
that makes more sense.
Okay.
All right. Thank you, Professor. Thank you, Ms. Moran.
Not a problem. All right. Yes, Mogus.
What was my question is, I don't know about much about ticketing system.
Okay.
So how do assign jobs to everybody? Is that assigned by somebody or by system?
Well, we will actually have a T session almost completely on ticketing systems where we'll kind of get into that a little bit more and explain kind of, a little bit more how they work, how the tickets come in, the life cycle of a ticket, how it moves through the group and stuff like that. So we will get into that a little bit later. We don't want to get too far into the weeds on this one.
We got you covered, Mogus. It's coming up.
All right, thank you.
Not a problem. Not a problem. And then we'll briefly touch on the different, the most common ticketing systems that are used out there and things like that. And then, give you a little more inside look as to how they maneuver through the departments. All right. Any other questions as we're moving in? All right. We briefly went over this on the initial safety as to, electricity, what it is, what it does, why we want to take great care with it. And essentially, we had gone over volts, amps, and watts. And watts is one of the main things you want to pay attention to with regards to power supplies, to make sure that you have all that stuff that you need within the computer. And you're essentially doing that by multiplying your voltage times your amperage. Where is it? There was a great plumbing analogy to it. I think voltage is the actual pressure of the water. Amperage is the diameter of the pipe. And then wattage is how much water is actually moving through it. That makes sense. So your diameter of your pipe versus the amount of pressure behind it gives you how much water you can move through a pipe at any given time. So that would be voltage, amperage, and wattage. And wattage is measured in ohms, which is the resistance to the flow of electrons. So when you're using your multimeter, you're going to be measuring ohms.
Professor Kelly, can you repeat that analogy one more time about the water going
Okay.
through the pipe?
Okay, yeah. So voltage is like the amount of pressure pushing on something. So if you have, like 5 pounds of pressure pushing on water, and then I guess one way you could put it is, and then amperage is the diameter of the hose. So if you have 5 pounds of pressure and you're pushing it through a garden hose, it'll go pretty good. Like you'll get a pretty good spray out of it. Now, if you use that same pressure, but you're pushing it through a fire hose, which is a much bigger diameter, the water is barely going to kind of ooze out of there because the pressure isn't enough to push enough water through to create a good flow.
Okay.
That's,
Okay. All
and
right.
the
So
amount of water that's actually passing through the pipe, that's your watts.
the amount of the power going out through the pipe is the watts.
Well, no, the
Okay.
amount of water is the wattage. So that's the amount of current that's coming through. That's the amount of water coming through. And then you have voltage, which is the amount of pressure being applied to that water. And then the the amperage is the diameter of the pipe that you're pushing that water through. Go ahead,
amperage is the what now?
how
the water
big around that pipe is, so
Okay.
if we have 5 pounds of pressure, or say like 50 volts, and then we have say 2 amps, which is going to be low, it's going to appear like there's more pressure behind it versus pushing it through a fire hose where it's just going to kind of drizzle out and there's not going to be much pressure there.
The amperage, got it. Okay.
Yeah.
Capiche.
Go ahead, DJ.
Sorry, you answered my question from two.
Okay. Okay. Let's see here. Now, different types of delivery. You have alternating current and direct current. Alternating current, it's going to oscillate between positive and negative, going back and forth. And say from the power plant, wherever's close to your house, excuse me, reset. Alternating current oscillates between the two. So going from, say, your outlet in your wall, in every house, it is alternating current. And then that would go to, say, the power supply in the computer, where the computer components all need direct current, which does not oscillate. It is a single directional flow. So the power supply's main purpose is to transform that alternating current into a direct current, which is something that the components can use. Now, from the power plant to your house, it is direct current. It is one of the more efficient ways of actually delivering that power. And then it changes from the demarcation point at your house into alternating, which is what most of our appliances use, TVs, what have you, lights, and all that. And then, but the internal components of a computer require a steady stream of direct current in order to actually operate. We have mentioned prior that in most of Europe, I believe Central and South America, Africa, most other continents operate off of 220 to 240 voltage. Here in the US, we operate off of 110 to 120 voltage. Now, I think we had mentioned, if you take a component from here in the US, you take it overseas, you plug it in over there, it's going to fry it because it's getting way too much power for what it's capable of handling. If you take something from Europe or what have you and bring it here, you plug it in, it's not going to have enough power to function. Now, it's not going to fry it outright, but you do still have a good chance of damaging that unit. So on the backs of computers, oftentimes they will have a little selector switch, little red switch right on the power supply next to where the cable goes into the back of the computer, and it'll say 220 or 110. So if you say receive a call from a customer and they say, hey, I have a problem every time I go over to Belgium, my computer works just fine. I bring it back to the US, it doesn't work at all. Right off the top of your head, you should be like, hey, there's a selector switch on the back. The problem is, when you come back, you need to set it so that it can actually function here in the US. And then when you go back, be sure you change it before you plug it in and turn it on. Thankfully, in most modern iterations of computers, they're making this an automatic switching mechanism so that when you plug it in, the power supply registers what's coming in, says, okay, I know what this is, flips it to 220. That way, no internal components are damaged, and it happens without you having to think about it. But on older power supplies, that still is an issue. You do need to selector switch for it. And I believe laptops, unfortunately, you may actually need to get a separate power supply because they're a much simpler version of it. Do you know, Marvin, if they've actually gone to where they're self-selecting?
For some reason, Kelly, I feel like
They might have. I'm just not 100% on that.
so I'm looking at a power supply right now, and it actually says 100 to 200 volts. So it almost makes me feel like the actual, that little box can handle both. You're just gonna have to have the correct ending for the European wall outlet.
Well, that's how they split halfway through. So I think that may be the case. So yeah,
I think you're on it, Kelly. I think it's already, they thought about it ahead of time. The only issue is that, with power supplies, I know when I worked at at Circuit City, we used to sell the European power adapters because they look totally different from ours. So I think you will just need that, and your power supply for your charging cable for your laptop will recognize it and work accordingly.
Okay. All right. Makes sense. Yeah, I figured they had set that up. I just couldn't remember ever actually reading concretely if they had. All right. So internal components in the computer, we have mentioned this before, takes 5 flavors of voltages. So there's 5 different types of voltages that the internal components will utilize. Can anybody tell me what one of them is? We'll call them out one at a time. So let's see. Let's start with Amber. What are one of the 5 voltages that a computer can use on the internal components?
I'm not sure.
You're not sure?
No.
All right, maybe we can get started. Avery.
Positive 3.3.
Positive 3.3. There's one. Mogus.
Positive 5 volts, positive and negative 5 volts, and
Well, you called out 2 there. Hold on. So positive and negative 5 volts. There's 2 left. Let's see who would know that? Frank.
Bigger number.
It's, oh man, it's like 12 point something. Oh, it's 12. Never mind.
They
Positive,
said
negative 12.
I muted you, Kelly, by mistake.
You are muted, Mr. Kelly.
I muted you by mistake, Kelly, and you were right, Frank. Positive and negative 12.
Cut me off.
My
Yeah.
fault.
No worries. Yeah, no, there's the 5 different types of voltages that you will come across for internal components. It is the positive 3.3, positive and negative 5, and positive negative 12. And that is a question that will come up. So that is a test question. So definitely one to remember, where they will say, like, I've got, they'll rattle off 3 and they'll say, what are the other 2 voltages that you would come across internally in a computer for direct current? All right. Here it is. And power supply, internal computer, you will often see it referred to as the acronym PSU, so Power Supply Unit. Here is a look as to pretty much what most of them look like. You know, they'll have fancier cases on some of them, but this is essentially what it will look like. It's a big box connected to the upper back corner of the computer, and you'll have a boatload of wires coming out of it to connect to the components that you have internally on your computer. And as we were mentioning, they do have the positive 3.3 volts. Ignore this right here. For some reason, they just kind of stuck it up there. So, you know, ignore this. So you got your
It's the hyphen that lets you know what's coming up under the bullet, but it's
Yeah,
so close
but-
by that 3 point. Yeah, it kind of can throw you off. It's not
They
a
should have been a
negative.
square bullet or a round one on that one. So yeah,
I
ignore
agree.
that right there. So you have your positive 3.3, and it is VDC, so voltage direct current. Positive and negative 5 VDC, positive negative 12 VDC, and that is every component in the computer operates pretty much off of this. Now, you don't necessarily need to know the hertz, so I wouldn't necessarily worry about that. You just need to know in essentially in the US and I believe about half of the Caribbean, they operate off of 110. You get into European and in most other places, they operate off of 220. And then there is that selector switch on the back that lets you operate between the two, but more modern computers are moving to automatic switching because it's just plain easier and there's no chance that you will actually just let it slip your mind. Yes, DJ.
I was just wondering, why is it that they use a higher voltage in European countries?
I mean, I believe it goes back all the way to like pre-World War II when they were developing the power grids. They were just developing on different standards. And the US is notorious for just saying, you know what, I'm not changing.
There to
use
be
metric,
different.
fine, you use metric. We're gonna use our own stuff. You know, so we're a little notorious into when we get set into something, we don't want to separate out from it. The rest of the world essentially went 220, US went 110. If you're old enough to remember back when cell phones were really starting to become widely adopted, the US was banking everything on analog signals because you could push a good amount of data across analog. They thought it was the most efficient way we could do it. And you know, the bandwidths, we already had them in place. We're good to go. We're moving. The entire rest of the world went digital, and they got way ahead of the US. And it was one of the few times that they actually turned around and said, you know what, maybe we should jump over to digital. And so they jumped on the back of that, and then we're able to actually start catching up on those particular technologies. But with regards to the power grid, there really hasn't been a need to switch over to 220. So they maintain it at the 110.
I wonder with the whole influx of electric vehicles, will we see some type of radical change? Because you know, a lot of EV owners charge at home, and I wonder would that 220 be a
specialized power adapters.
Right.
Install a wall unit that I think converts it to that different power grid so that you can actually charge.
I think
That's
that they
actually
have that. Go ahead.
That's actually what I was thinking about when I was asking the question.
Okay.
So it's
Yeah.
funny that
But
you.
you think you're talking about legit changing like almost every power line, transformer, resetting almost our whole power grid to be able to make that conversion. It's a lot. So will they make that change? Probably. They may start doing it a chunk at a time, like they'll focus on like the major metro areas and converting it just within those tight geographical boundaries, and then start expanding it further and further out. So that may be how we see it start to do those changes.
And also we have those charging stations that they popping up a lot too, DJ. So it's ways they're working around it, but very good question. And once again, it, like Kelly said, it may have been just one of those standards that was well before its time and just remained. And we just adopted a different standard. Go ahead, Will.
Yes. Two things. One on you guys were mentioning about the 3.3 VDC. It operates pretty much in all computers. 3.3 VDC, and the 5 VDC and 12. Can you mind just elaborating a little bit? Maybe some. I didn't catch on that. I'm still catching up on my reading on that. I don't. What's that? What's that about?
Okay, like, so all your components inside of your computer, the graphics cards, the motherboard, CPU, hard drives, everything in that
Right.
computer is operating off of one of these 5 standards.
These 5 standards. Okay.
Yeah, you have the 3.3, you have the positive and negative 5 volt, and then you have the positive and negative 12 volt. So every component inside that computer is operating off of one of these standards.
Okay, okay. So in other words, that's the amount that needs to the currency of the
Yeah,
electricity.
that's the amount that, you know, like if you're installing a hard drive, it may, like a solid state, it may not require a lot of power. So, you know, it may operate off of a, you know, like a 5 or something like that. So, you know, each component is going to have their own power requirements, and industry standards have basically put it to where all of it comes in based off of these 5 different voltages, because you don't want 50 different types of voltages coming into this computer, like, you know, a 3.72 and a 5.13 and all that stuff. I mean, imagine how many different types of power supplies and connectors you would have to create just to, you know, manage something like that. Everything would have to be pretty much custom built. So the industry kind of agreed on these 5, and this is what they're operating off of. And then there's a limited amount of connectors that they will operate off of too, to deliver these, you know, the voltages.
Limited amount of connectors.
Yes,
well,
there's a
like-
limited amount of types of connectors that they use to connect to these components to be
Okay.
able to use this power.
Okay.
It's
Okay.
essentially creating industry standards, you know, like why the vast majority of any small electronic you have in your house will operate off of either a AA battery or a AAA battery.
Okay.
That's why those are the most common, the easiest to get your hands on, because the vast majority adhere to those standards. You may have to use 6 of them in there to be able to get the power that they need, but it's going to be like a AA or a AAA. It's very rare you'll see like a C battery or a D battery, and 9 volts are becoming increasingly rare as well.
These are the 5 components: 3.3 plus 5 VDC. The second one is negative 5 VDC.
No, the second one is either positive or negative. That's
Or
2 different
negative.
standards.
Okay.
So you know, you have positive 3.3,
Yes.
positive 5, negative 5, positive 12, and negative 12. My writing is terrible. All right, there we go. So those are the 5 standards. Don't let this confuse you where you have that positive/negative. That's just them trying to save time with writing, essentially.
No, I figured. Okay. Those are the 5 that would operate in everything, in every device, and especially in all the world around the world, the United States and
Yes.
okay.
Internal components. Well, because if you're building a graphics card, you don't just want to sell that graphics card here in the US. You want to sell that in over in Europe, in Asia, in Africa,
Right.
Australia. You want to sell that as many places as you possibly can
Yeah.
based off of one manufacturing footprint, because that's the easiest way you do it. So you set up internally, these are the standards that are basically set forth. So you're like, okay, you know, maybe I need more than 3.3. You know, I don't quite need, you know, 5, but I can set it so that it can accept 5. And then, you know, use one of the connectors that will adhere to that. And then it allows you to basically market it all around the world versus just in one place.
Okay.
And so everybody kind of just piggybacks on these standards and utilizes them so that they can get their product used as much as possible.
To use as much
And
as
it makes
possible.
it easy for us that we don't have to make sure that we have that proprietary connector, that exact voltage to be able to handle the components we need. It simplifies things for us on that end too.
With these 5 components. Got it.
Yeah, with
Okay.
these 5 voltages, and everything inside the computer, inside that tower, operates off of direct current. So everything coming out in here, DC. When this comes out of here, you know, when it's coming out of the wall, I'm gonna draw like a really terrible plug here. It's gonna be awesome. So when it comes out of the wall, AC, that is a horrible C. I love that. All right. So yeah, out of the wall, you got AC from the plug. Plug carries it into the power supply. As soon as it comes out of the power supply, it's operating off of DC, direct current. That's
Okay.
important. That is important to know as well.
Okay. Yeah, I'm gonna screenshot this numbers here. And
I'll hold off here for just 1 second. Going to take a quick screenshot of my absolutely terrible graphics. If it will help you remember, that's great. Are there any questions with regards to this?
The second thing is, I think they briefly already discussed this. It's gonna happen because in South America they run by 220 as well, because it's based off European
standards. Yeah.
Yeah. So, but you saying that? Did you hear if they're already gonna change it? Like maybe.
I have not heard anything with regards to South America changing their standards over to 110, because again, it makes sense for them because basically the rest of the world operates off of 220.
Yeah.
Why would they change to adhere to ours?
I was just curious that since that subject was brought up. But
Yeah, I've not heard any whispers of that, and I think predominantly they operate off of metric too. So, you know, it's you know, us not wanting to adhere to the metric system and stuff like that as well.
Thank you, Professor.
No problem. No problem. Yep. There you go, Avery. So yeah, Avery was saying, remember about the band AC/DC. AC comes into the computer, into the power supply. DC goes out of the power supply. All right, did everybody get a quick screenshot if you needed to, or make notes? We can move on before I start erasing. All right.
I just bought me some cards to write down all my notes to go over again. So you can't see it because of the white screen, of course.
Yeah, this is like you moving your hand around.
Yeah.
Okay, I see. We see them now.
So I got I got these to hold my 3x5s. You see that? Yeah. And like I filled up one of these. I filled up
I really got the entire thing filled.
Yeah, I filled up one of these for 1001 and one of these for 1002. So yeah, it's
Because I'm planning on trying to take the 1001 and 1002 together, so I'm just gonna study them both. I can retain a lot of the information because of a lot of stuff I already know. So like for the power supply, for example, like I know what it is, I know how it works, but I didn't know the questions they would ask. So now I know they'll ask about 3.3, 5 negative and positive, and 12 negative and positive.
Yeah.
So I'll retain that. Now I know. So it shouldn't be a problem. And the acronyms, of course.
absolutely. All right. Inside the power supply. We kind of already went over this a little bit. This just kind of gives you a little bit better graphic on it. So, you know, you got your input, main input is the 110 to 220 voltage alternating currents, and then it comes in, gets converted over to DC. It operates on these different regulators for the voltages. And then this is, say, the 20 pin connector that would go straight down to your motherboard, the P1 connector. Also, power supplies operate off of rails, essentially, and each rail is 12 volts. And power supplies can operate off of multiple rails, depending on the power coming in. Oh yeah, yeah, we will get into that in the troubleshooting there, Marvin, but absolutely correct. So yeah, you should never see a power supply in this condition. And I mean, never see a power supply in this condition, because that means the outer casing has been taken off. All these capacitors are now exposed, and this is a very dangerous device. It does not matter if it's plugged into the wall or not, it still can manage to have enough charge in there to, you know, severely injure and or kill you. So if you are not an electrician, do not play around with one of these open. So, all right. Moving right along. We have already mentioned this, but here is a picture of what that dual switch will look like right here. And this would allow you to flip it over between 210 or excuse me, 220 and 110 by pushing it to either side. Depending on where you're at to be able to do this, although more and more this is kind of going away because of the self-selector. Here is, probably familiar with, is the power cable. That's where that will plug in, or also known as the IEC cable. Power cable that goes from the actual power supply to the wall. It's called the IEC cable. And this one right here, I'm going to point out right here. This little power selector right here, which you cannot see because of the actual color. Let's go with yellow. Do this. That's a little better. Right there, that little on-off power switch that is on the back of the computer, right next on, directly attached to the actual power supply itself. Now this is considered a hard power on-off switch, and when installing new power supplies, I will tell you this because of frustration, if you, whenever you're installing a power supply, if you go to turn it on and nothing happens right off the bat, first thing you check if you just installed that power supply is come back and make sure this is turned on. Many people tend to forget that. I am one of those people. I actually did that, and I was doing a lab, installed a power supply, moved on. I sat there for 15 minutes, ripping the computer back open, making sure all my connectors were sitting there, putting everything back together, trying it again, still nothing. And I did this 2 or 3 times. And then finally someone walked over and goes, "Hey, G, you hit the main power switch on the back?" So what are you talking about? And I went, flipped it around, and then turned the power switch on, everything powered right on. So always remember there is a power button back here as well as the one that is on the front of your tower. So any questions so far on that?
Professor, just can you repeat again the one that you circled? What's that again? The switch right above
that is the main on-off switch for your power supply.
the circle, the one, the little red switch.
The circle would be off. The slash would be if it's on. So this one here currently is off.
Okay. And so the one right above it, the main switch, right above the main switch that you circled.
It's like a toggle switch.
Like a toggle.
Yeah, it's like a light switch. Turn it on, off.
Okay, so that's like what, the emergency turn. That's like the.
It can be viewed that way. It's just a secondary power, you know, to initiate the actual power supply itself. But like if you can't get the computer to turn off at all, you know, your options are essentially you can flip that off, which is a hard cutoff on the power, or unplugging it, you have to be careful with that because you can severely damage internal components by doing that. If they're in the middle of processing something, you can cause significant damage. So that's like a last resort power off option you would use.
I think he's talking about the circle above the power
The
cord.
variable power.
Oh, are you talking about this right here? Or
Yeah,
you talking about
yeah,
this switch?
not that switch, Professor Cully, right above it. Yes.
This one? Oh, my apologies. My apologies. Thank you, Andrew. I appreciate that. No, that is the selector. This is what the selector looks like for the 220 and 110 voltage selector. That's what this is.
So that's a switch for 220 voltage only.
Yeah. So if you go over to Europe, you make sure this is set to 220 before you plug it in.
Okay,
You
so
come
that
back
has,
to the US, you switch it over to 110 before you plug it in.
so if you're traveling, that has, and you got to make sure that switch is on, not the main power one.
You make sure it's set to the right voltage.
That's what it is.
There is no on or off with this particular switch. It's either 110 or 220. Those are your two options.
I understand now. Okay, got it. Thank you.
So that is the only options you have with those particular ones. It's 220, 110. That is your only option. But like we were saying, more modern power supplies auto selects based on the voltage it's receiving. It knows which one to set the selection to. Sorry about that. I thought you were talking about this particular one here.
No, sorry. No, definitely. But I wanted to know what the one right above it. All right.
Okay, my apologies. I misunderstood the question. Any other questions with regards to this so far? Nope. All righty. Turn off that annotate. There we go. All right, power switch, which I was just talking about here, is a physical switch to turn off the on and off the power supply, and it is a hard power supply switch. Now, the buttons that you normally use on the front of the computer, that is considered like the on and off buttons, like on the front of the tower that you would normally select to turn your power on and off. That is considered what's called soft power. So when you press that, if you're gonna, like, if your computer freezes up, you know how if you have to press it and hold it before the computer will shut down if your computer freezes up? You ever had to do that? And what's happening there is when you press and hold that, it's sending a signal to the motherboard to basically say, hey, tell all components powers are going to be turned off in X amount of seconds. So whatever components are operating can all stop what they're doing in order to be shut down. That way they don't get damaged in the process. So it isn't a hard kill on the power switch. It's basically, it allows the operating system to kind of do what it needs to do in a very short period of time to kind of shut things down so nothing gets hurt. So, but you definitely want to remember that soft power. That is the button on the front of the tower that you would normally use to turn the component on or off. Yes, DJ.
So, so the soft power is basically like when you press and hold the button, it's just like a time period where it's telling everything to turn off. Whereas where you press the hard power, it just cuts everything immediately.
Yes.
Right?
So like if you flip that switch on the back next to the power supply, next to the IEC cable where that goes in, you know, if you flip this switch, there's no delay, no notification of the parts that the power is about to get turned off. It's literally, you know, like if you smell smoke coming out of that computer, that's the power switch you want to hit, because it's going to immediately cut off any power and stop everything right where it's at. So this would be like your emergency on-off power. The front, there's communication that happens with the computer. You know, you press that, again, it talks to the motherboard, goes through the CPU. CPU starts telling everything, hey, we're about to shut down, stop whatever processes you have, because, you know, power is going to be cut in X amount of time.
Okay, so when you do the soft or the hard power, when you press it to turn off, it's not going to like damage anything inside the computer like it would if you were to unplug it if everything was running, right?
No, yeah, if you do the hard power on the back, this one, that'd be just like you unplugging it. That is
So
a
it
quick
does.
kill of the power. There's nothing going through after that point.
Okay.
Soft power just allows that buffer so that any moving processes can shut down to minimize any chance of damage.
Got it.
Does that make sense?
Yeah. Yeah. You answered.
Okay. Any questions with regards to soft power? Definitely want to remember that and know that it is basically the button on the front of the tower. All right. Cables and connectors. My absolute favorite. Sarcastically so. But we're actually gonna have a tea session right after this that is nothing but cables and connectors. And
Great.
do what?
Oh, sorry, I said great.
Yeah, that was my thought too, especially when I read that chapter. That was the longest chapter in the book, not gonna lie. But it's one of those things, unfortunately, gotta have that knowledge, gotta understand it. So now, in order to get from the power supply to the different components, we need to have various types of connectors. So we have originally, you have the P1 power supply, which is this one right here. And it will typically have 24 pins, but many will have an adapter that will allow this 4-pin grouping to come off and connect somewhere else. Who can tell me what you would typically use this little 4-pin connector for? If it does disconnect.
Is it
P1
down?
goes right into the motherboard. Power that. What would use this one right here, this little 4-pin connector?
For fan speed,
Do what?
I'm guessing fan speed.
Fan speed? No,
I think
not fan speed. Good guess though, because we do have 4-pin connectors for fans. Well, go ahead, Mogus.
I think it's related to South Bridge connectors, like maybe the connectors and the South Bridge, maybe PCI or something. Get the power around there.
Good guess. Good guess. Scott actually had it in the chat. So good call on that one, Scott. It is the CPU power supply. So there will be an additional 4-pin connector that will go over and specifically plug in right next to the CPU to power that independently. And that's just the first connector that comes out of here. So, and that's right, you're mentioning it right down here. So it could be 4, 6, or 8 pins just to power up that CPU. The more powerful they're getting, the more they're needing. Back here. And again, they reiterate the positive 3.3, positive -5, and positive -12, all of which will be supplied to the motherboard.
So does that mean they don't have any negatives because they're all positive? Will they ever
there's
have a
positive and
negative?
negative? There is positive and negative going here. So you can see it right here.
Oh, okay, yeah.
Positive and then the negative right underneath it. Then there's the positive and the negative right underneath it. They'll use annotations like this just to kind of save space. And then the only one that does not have the negative is the 3.3. Questions so far? All right. Now, another type of pins that you will see coming out is this little 4-pin called Molex, which I believe refers to the type of plastic that they use to make it. So you get this little 4-pin Molex here. And those would go towards IDE drives. And then you have the mini Molex right here, which tends to go towards drive fans, like we were mentioning here earlier. That is a little 3 or 4-pin connector. Yeah, well, typically will be 4-pin, but coming out of the motherboard, you may see only 3 pins or 4 pins. What do you do if you only see 3?
Plug it in anyway.
There you go. Plug it in anyways.
Good job.
Because what does that last pin do?
Control the speed of the fan.
Perfect, Ashton. Thank you. So these little ones like this were typically used for floppy disks, but more often nowadays are used for fans. Here we go. Here is a SATA power supply cable that you'll use for different drives, be them mechanical hard drives or SSDs as well. They will not typically ask you about the voltage of each cable connector. So it's not necessarily something you need to know for the exam, but something that you should be aware of when you get out into the wild. So that is just to kind of be more efficient with your studying, be aware. And then these different colors on the wires for the older computers will indicate to you what the voltage actually is passing through there. But we have a schematic, I believe, coming up in a few slides that will kind of break that down for you. And then down here, you have the PCI Express power supplies, because many of these components that are going in there require their own separate power supplies or separate power connections rather than just drawing in power from the motherboard itself. And those typically are 6 or 8-pin connectors. And more often than not, you'll see those connected with high-powered GPUs. Questions so far? All right. Now, for the purposes of the exam, you do not need to memorize all of this. However, I do stress that if you're going to get out and work in the actual field, dealing with hardware, any stuff like that, you need to be able to read a schematic, know what you're looking at, and understand how it relates. Because if they're saying we need to upgrade our motherboards and you need to find out what motherboards would be acceptable use, you're going to need to know, be able to read the schematics to see which ones you can use, which ones you can't use based off the information you're getting. Also, if you're switching form factors of motherboards, you're going to need to know the connectors you have, like the front panel connectors for the tower you're putting it in, where they're going to actually hook up on the pins off the drives. You're going to need to be able to read these schematics and be able to tell where these things are supposed to go. And if you, I'm not sure if you guys have done the lab yet on selecting a new motherboard. In that particular lab, you need to be able to read the schematics. Has anybody done that one yet? On installing a new motherboard in Lab Sim or Test Out? Ashton did. Frank's working on it. So yeah, you don't need to necessarily memorize it for the exam, but at least be able to read it and understand it for work going forward. All right, form factor. That's definitely going to determine what type of power supply you're going to need. So.
Hey, Kellen.
Yo.
Want to take a quick break?
Oh, is it time?
It's
All right.
time. All right now.
Beautiful. Okay, so form factors will definitely determine the types of power supplies you will use, because as you remember, the ATX power supplies are the larger format, so you will have a likely a lot more components attached to it, so there will be significantly more power required to actually run it if you're going to run it at optimal levels. So the ATX will have the P1 connectors for the motherboard, and then possibly the break off 4-pin to go to the CPU. Then they'll have additional Molexes to go out for SATA and other drives and things to the actual motherboard. And then you have the mini ATX and micro ATXs will use significantly smaller power supplies because you cannot attach as many components to them. So it is not as big of an issue. And as we were briefly touched on earlier, they will split out typically. I mean, it must be in DC or direct current, but they will typically split out into 3 voltage rails. You have your 12-volt rail, your 5-volt rail, and your 3.3-volt rail. And the 12 and the 5 will provide positive and negative, and then the 3 obviously is just positive. And the rail basically just means it has a maximum amount of power that it can supply. Each rail is broken up in 12-volt segments, and then broken down into further ones. So like a 12 volts for 5.5 would be broken up, could be broken up into 2 5.5s. Powerful computers, more recent computers with the more advanced CPUs might actually require more than one rail to supply power to the actual motherboard and CPU. So, but in order to prevent frying out the chip, if it doesn't require 2 full 12-volt rails, they will have the overt power protection planned into it so that it will not give it way more voltage than it can actually handle. So your typical office computers will have probably a single rail, because there aren't many extra bells and whistles you're going to be adding to a normal office computer where you're just going to be using Excel, a couple few low-level applications and stuff like that. But if you have a digital animator or a graphics designer or somebody who's going to be rendering 3-dimensional graphics and things like that, you're probably going to need upgraded graphics, upgraded power supplies, and things like that to be able to actually handle the computing power that's going to be pushed through it. So when you're selecting your power supplies, you are going to need to look at the rating of that power supply and also what it is you're actually putting in your computer. You're going to need to know how many watts your motherboard is going to need, how many watts your CPU is going to need, your graphics card, if you're using a NIC card because the one in the actual motherboard you have got burned out, you need to make sure you have wattage set aside for that. All of your hard drives, optical drives, floppy drives, anything else you're going to be using, you need to add up all of that wattage to know exactly how much power is going to be required. And then on top of that, so that information is going to be listed in the actual documentation, but the documentation is basically telling you this is the standard voltage that is being used by this component at any given time. Now, under times of high computing or stress times, like if you're operating on a graphics card and you're just watching movies or playing low-level games, it's really not going to use that much power and probably use the standard power that you put in for it. But if you're using something that's going to really intensely use that component, it may actually draw more power than is required. So if you're calculating this based off of the average usage of your components, and you get a power supply that just matches those, like if you need 1,000 watts for your computer. That's the average usage of each component, and you add it up, it equals 1,000 watts, and you get that. What happens when you start drawing, like if you're trying to push the limits of that computer and you start drawing more power, what do you think is going to happen?
You burn out the power supply.
I mean, the power supply wouldn't even be able to supply that power. So it wouldn't necessarily burn out the power supply. You would be maxing it out, yes. But likely the system would just crash because it's trying to draw more power than is actually available to it. And if it can't achieve that power, it can just crash the system. So knowing that we can't just add up everything and then that's our number, what do you think would be a safe bet for a buffer zone? Like where do you want to kind of build it to make sure you're safe? Say we have 1,000 watts. How much more than that do you think you would use? Or would be safe when you purchase a power supply to be able to support it?
At least 100 extra, I say.
So 100 extra, so 10%.
I think 25%, 20 to 25% buffer.
20 to 25% for Jermaine. Anybody else got any thoughts? What'd you say, Chris? Your microphone is off.
Maybe like 30%.
30%? Anybody else?
50%.
50%. Who said that? Was that Jackie?
Yes.
All right, 50% for Jackie. So interestingly, I'm going to say 2 of you are correct. One of you is correct for the exam. One of you is correct for real life. When you are doing it for the purposes of the exam, you're going to want to increase it by 30%. So Chris, you were on it. For the purposes of the exam, when you were calculating up the wattage, you want a 30% buffer built on top of that for times of high usage. And that's something you kind of want to have built in. Now, this is where we deviate between the exam and real life. Jackie was correct for real life. You want to increase it by about 50% because if you're just building out that computer, you kind of want to future-proof it a little bit. You may be adding components. You may be upgrading components. You may be, doing a little bit extra to that computer going down the road, and you want to have a little bit of a buffer so that you can, add things to it without having to, like if you're going to upgrade your graphics card, you don't want to have to upgrade your power supply just because you're upgrading your graphics card every time. So you give yourself just a little bit of a buffer to future-proof that. So real life capabilities, 50%. 30% with regards to the exam because that allows you the buffer in case of height for high usage. Does that make sense? All right.
Professor,
Yes.
can you have to excuse me? I don't. I'm kind of a little bit off here. Can you like break it down to me again, just in layman's terms, what we're increasing 30% power for which is for the computer?
I got it, Kelly.
For the power supply.
All right, go ahead, Mark.
But like, thank you.
So Will, you got this PC and you bought it brand new.
Okay.
And over time, you notice that you wanted to add things to the computer, meaning you may not be a gamer, but let's say freaking Zelda came out when you bought it and it played it perfectly. But Zelda, the Return of Zeus, I don't know, the newer one came out 2 years later, and you put it in your computer and it didn't work. It didn't work as good. So you say, okay, I need to replace my video card because the graphics have changed. I need to replace my video card. So you went and go buy a video card that works for your computer.
Yeah.
but your power supply don't have enough power to supply that video card. The wattage wasn't enough. It wasn't, it didn't have the ability to perform, but plug and give that new video card what it needed to work. So the goal was, when you bought that computer brand new, you need to buy it with the thought process that I'm going to have this for about four plus years. If I wanted to buy a new graphics card, if I wanted to add a bigger hard drive, it has the ability to do so. So the only way you do that is when you buy a new computer, you think about it beforehand, because you'll buy a bigger power supply, or you'll think about the number on that power supply, or 2 years after you bought it, you replace that power supply with a power supply that has more power coming from it. So that's that 30% buffer for the test. But for real life, we say 50%. So most power supplies out of the box will be about 350, 450, but it's not uncommon that if you went to a place to buy one, you're buying one that's 800 watts, 1,000 watts, because it knows as you add to that computer, it's going to be a bigger draw from that power supply. So
Right,
it's,
you want to future-proof it.
you want to future-proof it. That's exactly what we're doing. That's the whole purpose of that 30 to 50%. You want to ensure that as that computer age and technology change, as you buy to change with that technology, you have a power source that can handle those new requests for additional energy.
Right, when computer changes and tech changes, you want to make sure
your power supply can handle it by having the wattage to handle those new things, because a new video card could be an extra 200, 300 watts that you wouldn't, if you didn't think about it, your computer's not capable of providing. But if you thought about it beforehand, you'll be able to, oh yeah, I can handle that. That's nothing. My power supply has it. I have power on reserve waiting for that.
I have a feeling this is going to happen a lot to a lot of customers in the future.
Well, if you're creating that PC, you're good, because typically you'll buy one that's bigger out from the beginning. But you're right, it happens. It's not uncommon that when you buy another graphics card, when you go to like a Best Buy, that computer is going to be optimized for that purchase for that day. I'm not going to give you much more than what you need to work for today. It's going to be really good, but it's set up for today. It's not it's just like Apple, the iPhone 12 that's out right now, that's for today, but don't think they don't have iPhone 13 ready. But I'm not going to give you all of the features for iPhone 13 because I want you to buy that one. But as tech, as people in the industry, if you're building a PC, you'll have it set up to work for later, but you can buy a power supply. You know now how to take it out. Well, you'll learn in a little while how to take it out, and it'll fit right in the same spot as your old one, but it'll have so much more power. So you won't be forced to buy a new computer. You'll just buy a new power supply and upgrade your computer. So it's just a part of that constant churn of technology. And that's why we're here, because we're able to do it. You know, we're going to be empowered to say, hey, you need a new graphics card, but if I change your graphics card out, we need to buy a power supply too, because that power supply that you have is not going to work. That's all.
Okay. And last thing, how can we connect this with the previous slides? Because I'm missing something here. Watts, like I don't like.
Okay, so watts is that's the horsepower. That watts is your number that you use to identify how much you have versus how much you need. When you go into Circuit City, or if you go on to these websites like I said Circuit City, I'm sorry, they're gone. Best Buy or the Micro Center, any of the places where you buy these parts and pieces, Amazon, the number that they're going to be looking for is how big of what type of power supply you want. I need 1,000 watt power supply. The one that's in my computer is only 600, and I need 400 more watts to handle the things that I'm adding. So that's the watt. That number is how we That's our number that decides what we need to upgrade to. It's by watts.
Right, by
And
watts.
now volts is is the current in which those items use, but watts is the number in which you pull and get those volts from. That big number like that.
Yeah, because watts is like a minor. It's not volts is the higher large amount of power which supplies it to the computer, the CPU, the whole CPU.
Well,
And
there's a formula that it's volts times amps equals watts. So watts is just your big number. So and within that number is where your volts and your amps lies. So it's all together, but we're not going to talk about volts because we know we only using 5 different volts, right? 3.3, 5, and 12. But watts, we need a lot more watts to push out to those volts to power those items. So
you need a lot of watts. You need a lot of watts to add up to volts, right?
To get your exactly to power everything.
Those volts are providing a lot of power supply for all these type of.
That's it, Will.
Like
You got it.
DVDs, video
DVD, graphics card, everything that's in there that's running, it's coming from the power supply.
All right, everything makes more sense now. All right, I appreciate it, Mr. King. That was good. Thank you, Mr. Martin.
Anytime. Miss Jackie, what's your question now?
I was gonna ask, what will the question look like on the test, on the exam for the percentage added?
Well, it'll say when you're adding up all the, like when you're looking at all the components that you want to put into this computer, how do you determine how much wattage you need in that power supply? Is what they'll say.
Okay.
So typically the answer would look like you add up everything and then add 30% on top of that.
It may be as simple as asking also, if you buy a power supply, or what are you buying? Like, what's the number that you're buying? It could be, and it may say 20%, 30%. It could be simple as that too, Miss Jackie. But because 30% is the industry standard for the test, not for real life. So they may just want to know if you know that it's 30%. So if someone else thinks you lock in. What you have for us, Mr. Mogus? What you got for us?
That means the more connector we have, that means we have more wattage.
Restate your question one more time.
Yeah, can we say?
You muted
I
yourself.
just muted you, Mogus, by mistake. I was trying to put your hand down, but go ahead and unmute.
That's going around today.
I apologize, sir. Unmute for us.
So the more connector we have in a power supply, that means we have more wattage because we can support more devices. The more we have connected in the power supply, does that mean?
You know what?
Yeah. Can we say that we have
It
more?
would be an indicator, but I would not say as a hard fast rule, because all those connectors that come off now, they make it so the power supplies, you can disconnect the actual bulk of cables that come into the computer, because so you can custom order which ones you need, because some people may not need 10 Molex connectors. They may only need like 4 and then like have 2 in reserve. Right. So the number of connectors can be an indicator, but not necessarily a guarantee.
And to piggyback on what Kelly's saying, let's say most power supply has 10 connectors coming out of it. That's not true, but let's say it does. A 10 connector power supply could be 500 watts. It can be 1,000 watts. It still got 10 connectors. That power that it's creating is coming from the inside, it's not directly represented on how many cables coming out of it. As long as it has that ability to create, it's powerful enough, it's going to be represented through 3 cables or 5 or 10 or 15. That power is still there.
Yeah. Any other questions with regards to that? All right. Okay. look through the gallery here. Let's go with Carlos. And tell me what number 1 is, please.
Yes. I think that will be, if I'm not mistaken, Molex.
Okay. How many pins?
4.
There you go. 4-pin Molex.
Good job, Carlos.
1, 2,
Thank
3, 4. Some of these pictures aren't necessarily the best, but we kind of work with what we got. Let's see. Kendall, can you tell us what number 2 is?
Yes. I'm thinking number 2 is it with the PCI Express family or?
It looks very close to that. It looks very, very similar to that. But the PCIe connectors will typically have 6 or 8 pins.
Okay.
But the way they look, that looks just like it. So yeah, you're very close.
Okay.
DJ, can you help out on that? Number 2.
That's the CPU connector power supply thing.
Okay.
There you go.
Good job, DJ.
I don't remember the exact name of it.
Do what?
Is it the CPU? Is there like a name for it? I forgot it. I just remember it goes to
It's the 4-pin main power cable, and sometimes you will see it connected to the P1, and then it will be able to actually unhook and connect into the motherboard to power the CPU. But you are on point with that. So CPU 4-pin main power cable.
CPU 4-pin main power cable. Got it. Okay.
All right. Next, Avery. Can you give us number 3?
Is that for USBs? I can't really tell from the image.
Yeah, the angle. Yeah, some
Yeah.
of the angles on these are kind of bad.
Because I'm just seeing like the back side of it.
Yeah.
I know it clips into something.
Oh, absolutely. Yeah.
So
'cause
let me pull up a motherboard image. Let me see. See if I could narrow it down.
Anybody else want to help out?
Is it in an IDE connector?
Typically this one here, this 4-pin Molex,
Uh-huh.
would be used for your IDE. So that's typically what this one is used for. Power supply.
Okay.
That one's for your CPU. This one is the 6-pin auxiliary. So it can be used for a couple different things.
That was a hard one, Avery. Gave you
Yeah,
the
that
hard
is,
one.
that's probably one of the harder ones there.
Yeah, I don't think I've ever seen one of those.
So what was the answer?
A 6-pin auxiliary power cable.
Does number 4 have 4 pins or 8 pins? It looks like 4, but there's a lot of cables.
Do what?
Is that a
Number
4-pin or an 8-pin? Like it looks like 4, but there's a lot of cables.
What, number 4?
Yeah.
Number 4 is 4 pins. So
Yes, 4
while you're
pins.
asking about it, Frank, which one is that?
Man, my guess would be Molex, but we already
Well,
did that one.
This one over here is Molex.
Yeah, we already did that.
There was another one where they did mention Molex. What do you think they would use this particular one for? There's two things that we mentioned it would be used for.
Is it a mini connector?
A mini what?
For fans and
Mini
floppies.
4-pin. Oh, what's that?
You're right. You're right there, Chris. And
Mini.
you're correct on the use. You're correct in the use, Ashton.
Is it a mini 4-pin connector?
It's with an
I'm
M.
getting close. Somebody help me out, please.
Is it Molex?
There you go. It is a 4-pin mini Molex, and Ashton was on point. This is for fans and floppy drives. Let's see. Jackie, can you tell me what number 5 is, please?
It's the 20 or 24 pin one.
What's it used for?
PCs and
I will agree. But what is its main purpose? What is that?
motherboard.
There
power
you go. There you go. That is the main 20 or 24 pin P1 connector. Good job, Jackie. And lastly, number 6. This one right here. Go ahead and give that one to Ashton.
SATA.
Immediate. Absolutely correct. That is the SATA power cable, typically used for drives. And again, Marvin, can you drop the student pace one in the chat as well as on Slack?
Will do.
So that everyone can kind of revisit these slides because they're real good reference points.
Got you.
Please, sir. Thank you. All right, here's our answers. Good work, everyone. Oh, now we got a matchup. Stop sharing here. Everybody can go into it on an earpod, do a quick match just to reinforce what we did. jewelry, ground ourselves. What did we forget to do?
Unplug the
Unplug?
computer.
There you go. We forgot to unplug it. It's still plugged in. So we got it. But yeah, absolutely. That's step number one. Power down, unplug, discharge extra power by holding for 5 seconds. That's always step number one. Then remove the side, ground yourself, unhook all the power connectors for the front panels, drives, motherboard, everything. Get everything unhooked. But before we do all that and start unhooking everything, what would be a really good idea for us to do?
Take pictures of everything.
Excellent. Excellent. Take pictures so we know where everything goes back to when we replace that power supply. Takes a few seconds. It can save you a whole lot of headaches. When I think my brother mentioned to me that I should do that when I'm working on the car, when I'm taking something apart and then about to put it together, take pictures as you're taking stuff apart. I felt like such an idiot up to that point because like I have that phone with me all the time and never once did it cross my mind to just start taking pictures on every step of the way. So when I go back, put everything back together, I can start just doing everything in reverse instead of just trying to figure it out as I go. So it's absolutely a great tip and try to keep it in the back of your mind when you do it. And then, so we disconnect everything, unscrew the power supply, remove the actual power supply. Then we go to put the new one in. We do everything in reverse. Go ahead and put everything back in. Make sure we've connected everything to where we need to go. And then we can disconnect ourselves from the ESD, lock in the side panel, and power it on and pray. All right. Time to climb. Let's do underwater this time. Oops, I don't think I can start this way. Sorry. All right, how many we got? We got 8, 10. We got 4 more students. See where we're at. 11. In another couple seconds, and we will dive in on this one. All right, you guys ready? Question 1, which of the following is a consideration when purchasing a power supply with the correct wattage? There we go. What feature of ATX systems prevents a user from turning off a PC before the operating system has shut down? So it's not a hard cutoff. Give the PC time to catch up. What type of power connector did a floppy disk drive typically use? It's on the smaller side. We got mini Molex on that. User attempts to turn on a computer and receives no response. The user calls the technician to report the computer is not booting and a faint smell of something burning. Which of the following tools will best help identify this issue? Don't think we went over that in the presentation, but we will go over it in a second. All right, last question. Power supply appears to be failing. The best way to test the unit is to remove it from the computer, open the power supply casing so you can test the capacitor with a multimeter. So that's true or false? Yes, we're doing a quick quiz in the presentation there, Layla. All right. Ashton, Frank, Avery rounding out the top three. Good job. DJ, Jermaine, bringing up top five. Work, everyone. All right. So who can tell me if you smell that burning sensation? What is it you actually want to do? What's the best tool you could use to test for that?
Yes, Ethernet tester.
There you go. Didn't quite mention it, but they actually have a power supply unit tester. You hook it up to it and it'll tell you if the power supply is working, functioning properly and completely. Because unfortunately, power supplies die in one of two ways, either quickly or very slowly. And I think we mentioned it earlier, a power supply that is dying slowly is probably one of the most challenging things you will come across as a technician to diagnose, because most of it's intermittent and you're noticing it because certain components aren't working properly because they're not getting the power that they need. So one of the easy things you can do is hook it up to a power supply unit tester. That'll tell you if your power supply is good, and then you can kind of proceed from there. Last question for the multimeter. You know, if you're not sure whether or not the power supply is working properly, do you open up the casing on the power supply and test the capacitors with the multimeter? No, why not?
Quick death.
Quick death, there you go. Can't put it more concisely than that. It's very dangerous to do so. It is a field swappable item, meaning you just take the whole unit out, send it off. Unless you are a qualified electrician, you do not want to be opening up that case. First question they had, how do you calculate the wattage? How do you know how much wattage you need?
Voltage times amperage.
Is that the
You gotta
first
add up
question?
all the watt needs of the stuff in your
There you go.
CT.
And then what?
Add 30% extra.
There you go. For the exam, for real life, what do we do?
50%.
There you go. Excellent. Here we go. So what do you guys think are symptoms of power supply issues? I kind of gave you a little bit of it, but what would be the big one?
Burning smell.
Burn smell? Yeah, that would definitely indicate a power supply problem.
Smoking.
Smoking. Any other
CPU
issues?
not working or not turning on.
There you go. Not turning on. Straight, just not coming on at all. That would be a huge indicator your power supply is not working. Now, if you just put one in and it doesn't turn on, like it's brand new, out of the box, you installed it, plugged everything up, put it back together, go to turn it on, nothing happens. What should be the first thing you check?
The switch in the back.
There you go. Switch in the back. Make sure it's turned on. And we just went over the steps to replacing the power supply. Does anybody have any questions with regards to that? Nope. Steps for almost every component, it's basically about the same until you get to actually getting to the component itself, and then that component at the end kind of changes out. For the most part, the actual physical steps you go through in swapping out any component, be it a RAM blade, a motherboard, a power supply, all of that, it's typically the same up until you get to right around the component. Okay, troubleshooting power supply. We just talked about this.
Could you screen share?
Did I what?
Could you screen share?
Sharing is caring, as Marvin always says, and I did not do that.
Hey man, they beat me to the punch, man. I was about to say something like maybe he just haven't done it yet, but appreciate it, Frank.
Yep. At some point I'll remember these things. It always jumbles my screens up every time I do that. All right, so like we were just talking about, they fail in two ways: sudden death or over time, and that's typically where you'll see random components not getting the power they need and just not functioning properly. And it'll be intermittent. Sometimes it'll work, sometimes they won't, and so they can be exceptionally frustrating. But if it's no power at all, get into the computer. Quick way to do it: just take your power supply, hook it up to a power supply unit tester, and it'll tell you if it's still functioning and you need to keep digging for a different issue, or if it's not functioning and needs to be replaced in the field. Questions so far on that? Go ahead. Who was about to ask a question?
Okay, I was about to ask, when it's dying slowly, so that's when you get error messages like blue screen, or would it just like turn off suddenly as well?
Well, no, see, like the slow death is kind of like maybe your graphics card isn't getting the power it needs. So you don't notice it until you really start trying to push your graphics card, and then that'll crash, you know, or your disk drives, you know, like your computer's working fine, and then all of a sudden your disk drives aren't working. And it'll be intermittent, like, so it'll work right now, but then like an hour or two from now, it won't work. And then a little bit later after that, it'll start working again. So it's like intermittently, it's only happening every now and again. It's not happening every single time. It's kind of like when you hear a rattle in your car and you take it to the car mechanic, they drive around the block and you're like, yeah, it's fine. Because that issue didn't occur when you were actually at the mechanic itself. So it's just, it's sometimes happening, sometimes not happening. And that's why it's such a frustrating thing to diagnose. So if you have access to a PSU and you know, maybe it's the second time you've seen this customer and they're talking about different issues, try hooking it up to a PSU real quick just to verify whether or not that's the issue. And then you can move past, you know, that particular problem. Because you don't necessarily need to take it out of the computer to actually hook it up. It's just cables that you would remove the internal plug components, plug it in the front, and then you plug into the power supply in the back, and it'll run a test on it for you.
And it would be like the same type of issue happening over and over, or would it affect like different parts of the PC, like not getting power?
The answer to that is yes. It could be the same issue happening over and over again, but not consistently. And it could be hitting different components. That's why it's so difficult to try to diagnose it if it's dying slowly.
Got it. Thank you.
No problem. Go ahead, Will.
The moment then, just to clarify, the moment you smell like electronic burn or something is not right. I just to going back a couple of slides, I remember you saying, or Mr. King, Mr. Martin was mentioning, once you see that, you hit the soft button on the front, turn it down, and then
If you smell electrical, like if you see blue smoke or smell burning,
immediately
hit the hard kill on the back of the computer.
back of the computer. Okay.
Cut
Always.
off that power immediately. That way, no further components are damaged.
Or unplug it from the wall. You want to
Yeah,
stop.
that's
that
another one.
quickly.
Yeah, just rip that plug out of the wall.
All right. So okay, that's what I wanted to make sure. I remember now. Okay. Okay. Got it.
So yeah, soft power, that's not the moment you want to use that. Soft power would be like you have a couple apps frozen, the computer's not really responding. So you go ahead and hit that soft power. Soft power tells the motherboard, hey, notify all compute, or BIOS, and notify all components, hey, we're about to shut down, stop whatever you're doing, and we're going to kill power. Hard kill is just like, I don't care what's happening, boom, it's gone. So any other questions with regards to power supplies? You're all experts. We can do a hot swap out right now. Now, I highly encourage you. I encourage you to do the test out labs every time we do them. But the power supply one is a really good one to do.
Really good.
So if you're not already messing around in the Lab Sim test out program, please start getting in there and watching the videos, doing the simulations, because they are very helpful. But to wrap this up, after going through this particular technical session, you should be able to identify the characteristics of a power supply and its connectors, select a power supply based on given specifications, describe how to remove and install a power supply, and identify common problems that can come up with power supplies and how to address them. Typically, it's swap out the unit. I think we can end the recording there.